Good morning, students. This is Addagatla Nagaraju, working as lecturer in electrical and electronics engineering, Government Polytechnic, Station Ganpur. So today we are going to learn DEEE 5th semester's AC motor subject. So in AC motors subject, single phase induction motors chapter we are dealing. So in single phase induction motors, capacitor start capacitor run motor we will discuss today. Capacitor start capacitor run motor we will discuss today. So in last class, what we have discussed based upon the construction methods. Based upon the construction methods, single phase induction motors have 5 types. Split phase resistance start induction motor, capacitor start induction motor, capacitor induction motor, permanent capacitor induction motor, capacitor start and capacitor run induction motor, and shaded pole induction motor. These 5 types of induction motors are available. In previous classes, we had discussed how the split phase resistance start motor will work, and then how the capacitor start motor will work. So we had seen capacitor start induction motor has high starting torque around 350 to 400% of full load. And then we had seen permanent capacitor induction motor, and we had seen the construction working principle, and we had observed it has a very good power factor among the all single phase motors. So we had seen electrolytic capacitor used in capacitor start motor. Okay. Now, on completion of this period, you would be able to know about capacitor start, capacitor run motor, capacitor start, capacitor run motor, and its main components and working of capacitor start, capacitor run induction motor, torque speed characteristics of capacitor start, capacitor run induction motor, and applications of capacitor start, capacitor run induction motor. Okay. So on completion of this period, you will be able to know the capacitor start, capacitor run induction motor main components and how it is working, and the torque speed characteristics and applications. Okay, these topics we will cover on completion of this period. And also, On completion of this topic, you would be able to know about shaded pole motor. Shaded pole motor. So components of shaded pole induction motor and how shaded pole induction motor will work, torque speed characteristics, and also applications of shaded pole induction motor we will see on completion of this period. This is the capacitor start capacitor run single phase induction motor. So it has two capacitors, one for starting and another one for running. So two capacitors are needed for capacitor start capacitor run induction motor. Due to the advantages with the use of capacitor during normal starting, a capacitor start capacitor run motor has developed. Due to the advantages with the use of capacitor during normal running and starting, capacitor start capacitor run motor has developed. It is similar to capacitor start induction run motor, except that the winding and capacitor remain in the circuit at all times. So we know that due to the advantages with the use of capacitor during normal running and starting condition. So at starting, capacitor will use to develop the high starting torque. At running, capacitor will use it to improve the power factor. Okay, it is similar to capacitor start induction run motor, except that the winding and capacitor remain in the circuit at all times. At all times. This is the capacitor start capacitor run motor schematic representation. Here it is the main winding and it is the auxiliary winding. It has starting capacitor, running capacitor. Starting capacitor is connected through a centrifugal switch and the capacitor running capacitor is connected in series with the auxiliary winding. Starting capacitor is present at the time of starting only with the help of centrifugal switch. After some time centrifugal switch is opened, then starting capacitor is opened from the circuit, but the auxiliary winding and also running capacitor remain present in the circuit. These are the capacitor start, capacitor run motor, capacitor start, capacitor run motor characteristics. Capacitor start, capacitor run induction motor characteristics are here. So, capacitor start and capacitor run in the circuit. Here the starting torque is around 180 to 200% of full load. Then the speed pickups up to 80% of rated speed. Then starting capacitor is removed from the circuit. Only running capacitor present in the circuit. These are the characteristics of capacitor start capacitor run motor. The running capacitor should have the following. It should result in optimum running performance. It should be continuous rating. It should be of short duty rating. Capacitor start capacitor run motor. Starting torque can be improved. Auxiliary winding contains two capacitors, one for starting, one other for running. These are the capacitor start capacitor run motor schematic diagram. The rotor is the cage type rotor. Rotor is the cage type motor. This is the main winding. This is the centrifugal switch. One for starting capacitor, one is the running capacitor. Okay, this is the auxiliary winding. Capacitor start capacitor run motor schematic diagram. So two value capacitor motor. Both the starting capacitor and running capacitors are in the circuit during starting. When the motor picks up speed, centrifugal switch disconnects from starting capacitor, moves to running capacitor. The running capacitor remain in the circuit during running conditions also. Both the starting and running capacitors are in the circuit during starting. When the motor picks up speed, centrifugal switch disconnects from circuit and removes the starting capacitor. Only running capacitor is present in the circuit. Running capacitor remain in the circuit during running conditions also. During running conditions also. Two value capacitor motor. So starting capacitance is larger in value. It is of electrolytic type, and starting capacitor permits high starting torque, and running capacitor is small in value. It is an oil type capacitor here. So starting capacitor, we had already seen that in capacitor start induction motor, starting capacitor has large in value. It is the electrolytic type capacitor. Okay, it permits high starting torque. And we had seen in permanent capacitor motor also, running capacitor should have been small in value. It is oil type capacitor, and also it permits for improving the power factor. Improving the power factor. Reversal of rotation of capacitor. Start capacitor run motor. Here we had reversed the main auxiliary winding connections. So we can reverse the We can reverse the motor by interchanging the auxiliary winding or main winding, or we can we can change any one, auxiliary winding or main winding, but not both. But not both. By changing the auxiliary winding connections or by changing the main winding connection, we can we can reverse the direction of the capacitor start capacitor run induction motor. Coming to the disadvantages of capacitor start capacitor run, that is two value capacitor motor. It is the expensive motor. Expensive motor. Coming to the merits, it is the best performance motor. Best performance motor. Starting torque high. Starting torque high. Coming to the applications in compressors, conveyor pumps, and other high torque loads. Compressors, conveyor pumps, other high torque loads, capacitor start capacitor run motor using. Coming to the centrifugal switch, it is used to take out electrolytic capacitor out of auxiliary winding circuit when the motor has attained predetermined speed. During starting period, centrifugal switch is closed and starting capacitor and running capacitors are connected in parallel. Total capacitance in auxiliary winding is the sum of their values. Sum of their values. So, centrifugal switch is used to take out electrolytic capacitor out of auxiliary winding circuit when the motor has attained predetermined speed. During starting period, centrifugal switch is closed and the starting capacitor and running capacitors are connected in parallel. Total capacitance in the auxiliary winding is the sum of their values. Sum of their values. And the starting capacitance is 10 to 15 times of running capacitor. We have already discussed starting capacitor has large in value and running capacitor has smaller in value. The motor operates as two-phase motor from single-phase supply. The motor operates as two-phase motor from single-phase supply. Constant torque is produced and not the pulsating torque. Constant torque is produced and not the pulsating torque. They have availability to start heavy load. They have ability to start heavy loads. They are extremely they have ability to start heavy loads. They are extremely quiet in operation, better efficiency. Better efficiency. So starting capacitor is 10 to 15 times of running capacitor. The motor operates as two-phase motor from single-phase supply. Constant torque is produced and not pulsating torque. They have ability to start heavy loads. They are extremely quiet in operation and it has better efficiency. It has better efficiency. Power factor is from 0.8 to 0.95. Because of permanent capacitor, its power factor is improved. Its power factor is improved. Shaded pole induction motor. This is the stator field winding. This is the rotor. So this is the north pole and south pole. These are the copper shading rings present in the pole itself. Okay. So shaded pole induction motor. The connection diagram of shaded pole induction motor shown in the figure. Here it is the stator winding. This is the rotor. It is a squirrel cage type induction motor. Here in poles there is a shaded band, shaded coil is there. It is a shaded part. Okay. Flux is passed with this winding. Here, due to the shading, the flux distribution is not equal. Okay, construction of shaded pole induction motor. It consists of squirrel cage rotor. Stator consists of silent poles. The poles are shaded. Each pole carries a short-circuited copper coil called shading point or shading coils. It consists of squirrel cage rotor. Stator consists of silent poles. The poles are shaded. Each pole carries a short-circuited copper coil called shading bond or shading coil. The portion of the pole which carries shading band is called shaded part of the pole. The remaining portion is called unshaded part of the pole. Unshaded part of the pole. This is the silent pole type shading coil. It is the unshaded part. This is the shaded part. Here the copper shading coil is present and these main poles are laminated to reduce the eddy current losses. Silent pole with shading coil. Shaded pole induction motor shown here. It is the shading bands are opposite direction. It is the left side, it is the right side. It is the right side, it is the left side. Okay, shaded bands. This is the supply to the stator, it is the rotor. Shaded pole motor with shaded coils shown here. It is a shaded part. Here the copper rings. It is also shaded part. Here also copper rings. In between, the rotor is present. Shaded pole motor with shaded coils. Copper generally shaded coil is a copper pad. Shaded pole figure. Shaded pole motor can be single speed or coupled multi-speed as shown here. Electrically and mechanically simple, it is inexpensive but has poorest efficiency and starting time. Best uses are usually household rather than industrial applications. In household applications, multi-speed, generally in coolers for high, medium, low, multi-speeds shaded pole induction motors are used. A shaded pole motor can be a single speed or tapped multi-speed as shown here. Electrical and mechanically simple in construction, it is inexpensive motor but has poorest efficiency and starting torque. Best uses are the household rather than the industrial applications. Generally in coolers, we will use this type of shaded pole induction motor. Shaded pole motor with flux distribution shown here. Shaded bands are opposite directions. Four pole shaded pole construction. North, south, north, south. These are the shaded poles. Shaded poles. Here is the shaded band, copper band. Here it is also shaded band. It is also shaded band. It has also a shaded band. Copper wire of 1 ton used for shading the coil. Principle of operation of shaded pole motor. Single phase supply is given to the stator winding due to the shading band on the poles. A rotating magnetic field is generated. Single phase supply is given to the stator winding due to the shading band on the poles. A rotating magnetic field is generated. Waveform of stator flux. Consider three instants T1, T2, T3 during positive half cycles of flux. T1, T2. At T1, current through the stator coil and flux increases due to the rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow in the short-circuited shading band. Consider three instants T1, T2, T3 during positive upcycle of flux. At T1, current through the stator coil and flux increases due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow in the short-circuited shading band. The direction of current given by Lenz's law to oppose the cause, that is increase of flux of stator field. Hence, there is crowding of flux in the unshaded part, weakening of flux in the shaded part. Hence, magnetic axis will be at the center of the unshaded pole. See the direction of current given by Lenz's law. It opposes the cause, that is, increase of flux of stator field. Hence, there is crowding of flux in unshaded part, weakening of flux in shaded part. Hence, magnetic axis will be at the center of the unshaded pole. At the center of the unshaded pole. This is the magnetic axis at the time t1. This is the shaded part, this is the unshaded part. This is the main flux phi m. This is the shading ring flux. Due to the shading ring flux opposes the main flux, here the flux weakens and here the flux strengthens. Then the magnetic axis is shifted at the center of unshaded pole, crowded flux, unshaded pole here. Working of shaded pole induction motor. At the instant time t is equal to t2, the stator current, hence the flux is maximum, rate of change of flux is minimum. Flux is maximum, but the rate of change of flux is minimum. The induced EMF in the shading band is very small, hence opposition to the main flux is negligible. The main flux distribution is uniform. Magnetic axis at the center of the pole. Here, at the time t2, there is a maximum value of flux, but minimum rate of, there is almost zero rate of change of flux. Due to that, the flux induced EMF induced in the shaded band is minimum, then the opposition is minimum, then the flux distribution is uniform, and the magnetic axis is exactly middle the pole. Exactly middle the pole. Working of shaded pole induction motor at T is equal to T3. At T is equal to T3, the stator current flux is decreasing due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow, the direction of which is given by Lenz's law. At T is equal to T3, the stator current and flux is decreasing due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow, the direction of which is given by Lenz's law. Given by Lenz's law. It opposes the cause, that is the decreasing of at T is equal to T3. The stator current and flux is decreasing due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow. The direction of which is given by Lenz's law. It opposes the cause, that is, it opposes the decrease of flux. The flux due to shading band is in the same direction as the main flux, so there is crowding of flux in the shaded part compared to unshaded part. The magnetic axis shifts to the center of the shaded pole. Here, at T3, the flux is shifted, crowded to shaded bands. Now the magnetic axis shifted to center of shaded part. This is the torque speed characteristics of shaded pole induction motor. Advantages: simple in construction, cheap, and extremely rugged, and no centrifugal switch is required. Simple in construction, cheap, extremely rugged, and no centrifugal switch is required. This is the shaded pole induction motor. Shaded pole induction motor. Coming to the disadvantages, starting torque is poor, efficiency is very low, very limited over load capacity, very limited overload capacity. Starting torque is poor, efficiency is very low, very limited overload capacity, very limited overload capacity. Coming to the summary, capacitor start capacitor run motor is one of the split phase motors. Capacitor start capacitor run motor is one of the split phase motor. One of the capacitor remain in the circuit during running condition also. Capacitor start capacitor run motor is one of the split phase motors. One of the capacitors remain in the circuit during a running condition also. High starting torque, better efficiency. High starting torque, better efficiency, improved power factor. Capacitor start capacitor run motor is one of the split phase motors. One of the capacitor remain in the circuit during running condition also. High starting torque, better efficiency, improved power factor. Improved power factor. This, the type of single phase induction motor having the highest power factor is option A, shaded pole type motor, second split phase type motor, third capacitor start type motor, fourth capacitor run type motor. The type of single phase induction motor having the highest power factor is option A, shaded pole type motor, option B, split phase type motor, option C, capacitor type motor, capacitor start motor, option D, capacitor run motor. Answer, capacitor run motor. Capacitor start capacitor run motor is basically single phase induction motor, single phase reluctance motor, two phase induction motor, three phase induction motor. So capacitor start capacitor run motor is basically two phase induction motor because the main winding and auxiliary winding remain permanent in the starting and running conditions also. Starting and running conditions also. Capacitor start capacitor run motor is basically two-phase induction motor. Two-phase induction motor. Capacitor start and capacitor run motors are used in option A hoist, option B rolling mills, option C mining, option D refrigerators. Capacitor start capacitor run motors are used in option A hoist, option B rolling mills, option C mining, option D refrigerators. So capacitor start capacitor run motors are used in refrigerators because it is a constant load operation and used in the compressors. Next, the direction of rotation of two capacitor type induction motor can be reversed by reversing option A main winding only, option B auxiliary winding only, option C either A or B, option D both A and B simultaneously. The direction of rotation of two capacitor type induction motor can be reversed by reversing the main winding or auxiliary winding, either A or B. Either A or B. Two capacitor type single phase induction motor is generally coupled with the air conditioner compressors because it option A is cheaper, option B is quiet in operation, option C has high running torque, option D has low starting as well as running currents. Two capacitor type single phase induction motor is generally coupled with the air conditioner compressors because it has high running torque, has low starting as well as running currents, has low starting as well as running currents. Capacitor start capacitor run induction motor basically a dash motor. Two phase option B AC series motor, option C commutator motor, option D synchronous motor. Capacitor start capacitor run induction motor basically a two-phase induction motor because the starting winding and running winding, auxiliary winding and main winding both are remain present in the circuit. Next, two capacitor type induction motor have the main drawback of option A high cost, option B low power factor, option C pulsating torque, option D poor starting torque. Two capacitor type induction motor have the main drawback of option A high cost, option B low power factor, option C pulsating torque, option D poor starting torque. Two capacitor type induction motor have the main drawback of Poor starting torque. Poor starting torque. Coming to the frequently asked questions, explain the capacitor start capacitor run motor. Explain the torque speed curve of two value capacitor. Write the advantages of two value capacitor over other types. Explain the capacitor start capacitor run motor. Explain the torque speed curves of a two value capacitor. Write the advantages of two value capacitor over other types. Okay, thank you.